Okay, shh. Here we go. The homework this week then was, we've called this Integration 1 homework, first homework on integration. We've actually done lots more integration than this, but this is where we are with it. So, it's funny, isn't it? We said it was integration, but it starts with a thing that says dy by dx. It's all about differentiation. The gradient of the curve is given by this expression here. Oh no. 1 minute. Okay, that makes great stuff on the video, isn't it? Right. Shh. So, basically this means that something has been differentiated, and the answer when you differentiate it was 3x squared minus 2a. Now we're told 2 points that this curve passes through, and we need to find the equation of the curve. Well, that means we need to find what was differentiated to give this. What's the reverse of differentiation? Integration. So we're going to integrate. So y is the integral of 3x squared minus 2a dx. Now I am anticipating lots of you will have made a similar mistake at this point. Maybe not lots of you, but some of you will have made a similar mistake. And that is, you will have seen this bit that says 3x squared and done that bit great. 3x squared, add 1 to the power, that's 3x cubed. Divide by the new power, so we're dividing by 3, so we get x cubed. We know that because if you differentiate x cubed, you get 3x squared. Great. Then, you might have written minus 2a squared over 2. And even cancelled out the 2 to get minus a squared. Why is that not the right answer?
A is a constant, not x.
This is it. A is a constant. And because A is a constant, that means it's a number. So that means this term says something like 3x squared minus 8, if A happens to be 4. And if you integrate 8, you don't get something involving A squared. If you integrate 8, you get 8x, don't you? If you integrate a number, you get that number times x. So this says 3x squared minus 2a integrates to x cubed minus 2ax. It's still not correct. What am I missing? Plus c, constant integration. Now, we've got our expression involving x and y, but there are 2 things we don't know in this. Fortunately, we have 2 bits of extra information to help us out. So we'll sub in those values. At the point 1, 4, that means that 4 is 1 cubed minus 2a times 1 plus c. So from that bit we get one equation. We also had this going through the point minus 2, 7. That tells us that 7 is minus 2 cubed. Now hang on, what is minus 2 cubed? It's negative 8, isn't it? Minus 8. Minus 2a times minus 2. So I think that makes that plus 4a plus c. So we're looking for these 2 equations, which if we simplify these a bit, they actually might be better written as being 3 equals minus 2a plus c, and 15 equals 4a plus c. There we go, we've got simultaneous equations to deal with. So all we want to do now is to think how we would solve these. It's up to you what you do. I might think, well, an easy way to do this would be to do the bottom one, take away the top one. That makes sense, doesn't it? If I do 15 take away 3, I get 12. If I do 4a take away negative 2a, I get 6a. If I do c take away c, I get 0. So a equals 2. Tremendous. If a equals 2, we just need to sub that back in to find c. Therefore 3 equals minus 4. Oops. Minus 2a, that would be minus 4, plus c. So c is 7, And we've got our final answer is y equals x cubed minus 2a, so minus 4x plus c, so plus 7. There we are. Happy? Quick check to make sure things are making sense. If we differentiate this, you get 3x squared minus 4. 3x squared minus twice a would be 3x squared minus 4. So it does tie in with what we began. There we go. It was 8 marks, because that's in some ways the toughest kind of question, isn't it? Where you get one sentence, okay, 3 sentences, but you get one small little chunk of writing, not much to go on, loads of marks thrown at it. But if you're logical and work through it step by step, you can get there to the end. We gave question 2 for you to do as well, another past exam question. What do we have to do here before we can integrate? We have to expand the brackets. You are correct. So for part 1, this is going to become x cubed minus 4x, the x to begin with. We're then going to add 1 to the power and divide by the new power, so our integral is going to be, go on Molly, you integrate it for us.
X to the 4 over 4 minus 2x squared plus c.
Very good. Why did you get 2x squared from 4x? Where did the 4 go? Is it right? So why did that happen? 4 over 2. We had 4x squared over 2, which gives us 2x squared. Very good. So 3 marks for that. Part 2. Hence find that integral. Well, this is now between 1 and 6 as our limits. So that is basically the same question, isn't it? But between 1 and 6. Remember the difference if you've got limits there. If it's a definite integral, you don't put plus c in. Oh, it's the 4 over 4 minus 2x squared between 1 and 6. What you do is you put the numbers in order, so 6 in first. Where that 2 came from? 6 to the 4 over 4 minus 2 times 6 squared. Take away a quarter minus 2. And carefully sort this out. 6 to the 4 is quite a lot, isn't it? Anybody come up with an answer for this? Am I having to do this myself? Oh, it's in the wrong mode. Hang on. 6 to the 4 over 4. Take away 2 times 3 is 6. Take away quarter minus 2 inside some brackets. Gives me 1015 over 4. We agree with that? Or if you want to write that as being 253 3/4. That. Okay. Brilliant. There was a third question. Go on, Joe.
If you got part 1 wrong but then did the right thing with the answer from part 1, how many marks would you get?
Considering it was 2 marks, I think only 1. Jump. That was jump. Was that right? 1 mark.
Yeah.
Right. Now this was a bit separate. It was on an integration thing, but to pad it out and keep on your toes, we had a lovely logarithms question. I have a sneaking suspicion that as a class we've done this question before. I think I've taken this from the exam paper and done it on the board. Does it ring bells to you as well? So what we do is we take logs of both sides. You can choose the base. Which base did you choose? You just do it with log base 10. Okay? So log 8 to the x is log 3 to the x plus 1. Remembering our laws of logarithms tells us that the x comes down to the front, and the x plus 1 comes down to the front of that bit, which means we can now multiply out these brackets. So that is it completely simplified and expanded. We now want to collect the x terms together on one side of our equation. So we've got x log 8 minus x log 3 is log 3. And maybe would have done this in slightly fewer steps than this, but we're showing all the details, aren't we? Take x out as a common factor and divide through to get x on its own. And we end up with all the excitement. (1.12) to 3 significant figures. Okay? And maybe you did that part of the question in a separate little book that you keep this kind of question in. You know, maybe it's a log book. Right. That was a terrible joke, and that's maths.